Good afternoon. Today we are continuing on, we are doing a PO4. It is a PO, it is a power objective. So this is one on the test. You have to pass this objective. If you don't, you are required to retake it. Course objectives, if you don't pass, as long as we're passing 80% by the end of the year, you're okay to move on. Power objectives, you have to retake. I always strongly recommend, even if it's just a course objective, we're gonna retake it to make sure we have the understanding. Power objectives, super important. I can find the greatest common factor of a set of numbers. This will be important for when we're simplifying. Finding those greatest common factors. It helps us with word problems, helps us with simplifying. So first thing we need to know, if it's the greatest common factor, well, what is a factor? A factor is a number that goes evenly into a given number. So a factor is a number that goes evenly into it. The number that you multiply by something else and it gives you that number. So an example would be factors of 12. Factors of 12, when you're looking at all the factors, you think factor buddies. What number times what number will give me 12? Who can give me some ideas? Joe? Henry?
3 times 4.
3 times 4, so 3 is a factor and 4 is a factor. What's another factor pair, AJ? 6 and 2. And what is another one? Finley?
12 times 1.
Yeah, 1 and 12. Those are all factors of 12. I could take 12 and divide it by any of those numbers and I'll get an even whole number. Not even, I'll get a whole number. It will divide evenly. There's no fractions, there's no remainders. Right? So when we look at factors, we're looking at those factor buddies. Those numbers that go into that number. We can divide it by them and get those whole numbers as our answers. There are different methods for finding the greatest common factor. So first method is listing. So here's what that means. So we have F, C, G. So our first step, F, is list all factors. That's where that F comes in. Find all the factors like we did for 12. Find all the factor pairs. All your I call them factor buddies. All the factor pairs of each given number. So when we're finding greatest common factor, we're looking at least 2 numbers. Could be 3 numbers. The C is circle the common factors. Which numbers do they both have listed? They will share some and they'll have some that are different. Circle the ones that they share. And then G is identify the greatest, that's where that G comes in. Identify the greatest common factor. What's the biggest number that they both share? How do we feel about the listing method? Okay. That one is a little more basic. The problem with using the listing method is sometimes we forget factors that go into a number. You might forget a factor pair. You might forget 6 times 2 also equals 12. And then that's gonna throw us off because that greatest common factor that they share might have been in there. So we have another method called the table method. And I'm gonna show you what that looks like down below when we work with working it out underneath. So I'm gonna erase this so I can scroll up, so we can really see how to use that table method. So let's say we have two numbers, 40 and 72. And we want to know what the greatest common factor is of those two numbers. So when we do that table method, we're gonna make a table. And we're gonna have 40 and 72. And I'm gonna look at 40 and 72 and I'm gonna say, what is one number that I can pull out of both 40 and 72? Ellie,
9.
not 40 divided by 9 is not a whole number. Colton?
4.
4. Okay, so I'm gonna write 4 over here. And I'm gonna say, okay, 40 divided by 4 is 10. 72 divided by 4. Let's see, 4 goes into 7 once. That would be 32. 4 goes into 32 8 times. So if I divide a 4 out of 40 and 72, are you writing this, Leo? If I divide a 4 out of 40 and 72, I get 10 and 18 left. Can I divide anything else out of both of those numbers? Finley?
2.
I could divide a 2 out of both of those. So I'm going to say, okay, now 2. 10 divided by 2 is 5. 18 divided by 2 is 9. Can I divide anything out of 5 and 9? No, I can't go any smaller. So I divided two numbers out. What do you think I'm going to need to do with those two numbers? Henry?
Add them.
Not add them.
Multiply.
Multiply. Whatever numbers you all divide out, we multiply them. So my GCF would be 4 times 2, which is 8. Does that make sense?
Mm-hmm.
If we did our listing method, whoops. Okay, we've been not wanting to work it. All right, if we did the listing method, we have 40 and 72. What are my factor buddies for 40? Laurel, give me a factor buddy.
10 and 4.
10 and 4. What else? Ellie?
20 and 2.
20 and 2. What else?
5 and 8.
Any other factor pairs? Violet?
4 and 1. 40 and 1.
40 and 1. Any other factor pairs? Joe? I think that's it. So now let's look at 72. What are our factor pairs for 72? Henry? 8 and 9. What else can we multiply together to get to 72? Joe? Laurel?
6 and 8.
What else? Gavin?
72 times 10.
What else? Ellen?
18 and 4.
18 and 4. What else? Joe?
So 2
2 and 36, we got those. There's more. Victoria?
6 and 12.
6 and 12. What else? Figure it out. Ellie?
Oh, no, that's right over there.
Joe?
3 and 24.
3 and 24. This is why it's hard to do the listing method. Was it easy to come up with factors for 72? No, we kept missing some, right? So it's easy to miss some of those factor pairs when we're listing them all out. But if we go back and we look, let's see, we've got 1 and 1. Well, sorry, I should have circled them. 1 and 1, 2 and 2. I've got 3, but I don't have 3. 4 and 4. 5, but no 5. 6, no 6. 8 and 8. 9, no 9. 10, no 10. Then we've got 20 and 40 that are not down here. So looking at the 4 that I circled, the 4 that they have in common, what's the biggest number that I circled? Henry? 8. So we get the same answer, but we run the risk when we do the listing that we miss some of our factor pairs. If I had forgotten to put 8 and 9 on there, I would have put my greatest common factor was 4, because I forgot to list some factors. So it's okay to list factors and use that, but you run a risk of missing the greatest common factor. That's why we teach you the table method. Let's try using the table method for 12, 30, and 60. If we were to list them all, we would list them the same way, circling the one that all 3 had in common, and find the biggest number that all 3 have in common. Well, let's see how we do it with the table method. So we're going to make a table. So we have 12, 30, and 60. What number can I divide out of all 3 of them? Clara?
6.
What is 12 divided by 6? Say it out loud for me. What's 30 divided by 6?
5.
What's 60 divided by 6?
10.
Now what can I divide out of 2, 5, and 10? Nothing. Clara found that greatest common factor right away. We don't have to multiply that 6 by anything. But what if, when we looked at these numbers, we said, oh, I know they're all even. They all end in an even number. I know I can divide a 2-0. 12 divided by 2 is 6. 30 divided by 2 is 15. 60 divided by 2 is 30. Can I divide anything out of those 3 numbers? 3. Joe?
3.
Now I can divide a 3 out. 6 divided by 3 is 2. 15 divided by 3 is 5. 30 divided by 3 is 10. This time I have 2 numbers I pulled out. What do I have to do with those numbers I pulled out, Grace? Multiply them. 2 times 3 gives me that same answer of 6. So sometimes you find that greatest common factor right away. Sometimes you have smaller numbers and you have to keep going until you can't divide anything else out. Then you multiply whatever it is that you pulled out. Does that make sense? How are we feeling about the table method? Good. Okay, some of us are like, it's new. Sometimes it takes practice. Okay, this is why we're going to have some homework to do, right? Some problems to work out so we can get that practice in. I highly recommend you put in that second set that I put on there. So you remember, if I just pull out one and then I have to pull out another, I put that multiplication symbol in there. That dot needs to multiply. As a reminder, if I pull stuff out, I need to multiply it. Clara?
Could you put, like, you could divide 3 by 12, like, do 3 first and then 2?
Yes. Yep, if you looked at 12, 30, and 60, you go, oh, I know I could divide 3 out of all of those, and you did the 3 first, the numbers you get under it, you would be able to divide that 2 out. So it doesn't matter the order, because 2 times 3, 3 times 2, they both equal 6. Okay, good question. So numbers are called relatively prime. Sounds pretty cool if you say it with a British accent. I'm not good with accents, but Mr. Schultz, he's good with those accents. If their only common factor is a 1, they are not prime numbers themselves, but are prime when compared to each other. 8 and 15 would be an example. If we look at listing out the factors of 8, we have 1 and 8, 2 and 4. And if we look at 15, we have 1 and 15, 3 and 5. Whew. The only factor that they share is the 1. So if the only factor that they share is a 1, we say they are relatively prime. So if we're looking for a greatest common factor and it's only a 1, you could just write that they're relatively prime. They are not prime numbers themselves. 15, it's not a prime number. I have other numbers I can multiply together to get to 15. But it's called relatively prime because that's all that they share. Does that make sense? Okay. So let's look at some work. Turn your page. We are going to find the greatest common factor of these sets of numbers. You may use either method you wish. It's possible that the numbers will be relatively prime. You must show your work. So some of us are going to try to do mental math with this. We're going to look at 24 and 84 and say, ooh, let's see if I can figure out what factors go into both, and then just write down the answer. Are you going to get credit for doing this homework page if you just write down the answer? No, because the directions say, show your work. It is always important to read the directions, and we need to show our work. Okay, we do not get gold stars for doing mental math. No gold stars in 6th grade. I like to give gold stars for other stuff. But when we do math, show your work so we can see where we go wrong if we make a mistake. When we come back to study it, we understand how to do it when we can look at the work that we've done. Let's do 24 to 84 together. I think you guys know how to do the listing method, so I want to give us a little more practice with the table method. So I'm going to do 24 and 84. What is a number that I could pull out of both 24 and 84? Both.
12.
12. What's 24 divided by 12?
2.
What's 84 divided by 12?
7.
Can I divide anything else out of 2 and 7? So my answer would be 12, because that is the only number that I pulled out. Some of us might have said, oh, but I put 2, because I know 24 and 84 are both even numbers. 24 divided by 2, if we had done that, would be 12. 84 divided by 2 would be 42. What can I divide out of 12 and 42? Elliot? I could do another 2. 12 divided by 2 is 6. 42 divided by 2 is 21. What can I divide out of 6 and 21? Cam?
5, 3.
Yeah. 6 6 divided by 3 is 2. 21 divided by 3 is 7. I can't divide anything out of the 2 and the 7. So now I have 3 numbers that I pulled out. I need to multiply all 3 of those numbers together. 2 times 2 is 4. 4 times 3 is 12. So if you got lucky like Bo did, and you found that greatest common factor right away, you only pulled that one number out. A lot of times, we have to keep going down. Whatever numbers you're able to pull out, those are the ones that you circle and multiply. Joe?
If it's relatively fine, and we can't do anything to it, do we have to do a listing one?
So, Joe's already looking at the next one. We look at our table. I've got 15 and I've got 49. Okay, I can divide a 3. Oh, I can't divide a 3 out of 49. Can't divide a 5 out of 49. Can't divide 15 out of 49. So if I can't do it, I'm going to say 1, and I'm going to say relatively prime. So if you want to use the table and you can't pull anything out on the table, then you know it's a 1, because you can pull a 1 out, right? If you're listing, the only one that you could circle is the 1. So you don't have to use the listing if it's relatively prime. You could just look at it with the table and you just can't pull anything else out. Any other questions on this page? All right, let's look at our next page. This page, there's not a lot on it. We have a lot of workspace for you to be able to show your work. Oh. Next page, oh, look at that. We have word problems. You are creating prize bags to give guests at your birthday party. You have 18 kazoos, 45 fake tattoos, 36 stickers with famous mathematicians on them. What is the greatest number of identical prize bags you can make using all of the items? What do we have to do with these 3 numbers? We need to find the greatest common factor. How many identical bags? We're doing the same math. So you can make that table, 18 and 45 and 36. What is a number that I can divide out of 18, 45, and 36? Elliot? 3. 18 divided by 3 is 6. 45 divided by 3 is 15. 36 divided by 3 is 12. Can I divide anything else out? Finley? I can divide a 3 out. 6 divided by 3 is 2. 15 divided by 3 is 5. 12 divided by 3 is 4. Can I divide anything else out of all 3 numbers? No. So what is my next step? Ellie?
You multiply the 3 by 3.
The numbers I pulled out, I multiply together, and I get 9. Now, I need to label this. 9 what? 9 prize bags. Oops. Now it says, how many fake tattoos will be in each bag? Finley?
Do 45 divided by 9.
Uh-huh.
Do 5.
Yep. So 5 tattoos. So Finley said there are 45 fake tattoos, there are 9 bags, so 45 divided by that 9 was 5 tattoos. So you've already done the math with the table method. You just need to figure out which one was the tattoos. Does that make sense? So don't get overwhelmed by doing word problems. It's the same math. We just have to figure out which numbers we're using to put into our table and to answer the questions. Okay? At the bottom, you will notice it says time for review. Because our tests are going to be starting with objective 1, right? We're gonna be tested on what we learned last week. We're gonna have review pages, review problems, to remind us of what we learned. Last week was a long time ago. Big fun weekend. I forgot what we did last week. Where do you think I can find the definition of a whole number? In your binder. Go back to that objective. We wrote out the definition. So you're gonna write it, and then you're gonna give an example. Whenever we have these time for reviews, go back to that objective in your binder. You've already done it. If you don't remember what it is, refresh your memory. Okay? We always want to be reflecting back on previous work, so when it comes time to the test, we remember it easier. Joe?
We have to define the whole definition of a whole number right in front of God.
So the definition of a whole number is positive number, not decimal or fraction. Yeah, you have to put all of that. So Joe's got a good point. Should I write really big? I'm gonna run out of room. If you say to yourself, I don't think I can write that small, what do we have right next to our answer page? We have a blank page. You could write the sentences bigger on that page. You could say whole number and then give the definition and example if you need more space. Okay, that page before you can use to answer. You can use it as workspace. Any other questions on today's assignment? All right, if you are watching this at home, I hope you are well. I hope to see you soon. Have a wonderful day. And don't forget to like and subscribe. Remember, I want to try to have more subscribers than Mr. Schultz does. So like and subscribe to my YouTube channel. Get brothers and sisters and moms and dads to subscribe to my YouTube channel. And we'll see if I can get a bigger number than him. Have a wonderful day.